Hi guys, welcome back to J2EE tutorial. This is the fourth video tutorial of J2EE, which is Advanced Java tutorial. So the previous tutorial we discussed about the features about Java 7, what and all new features they have implemented in Java 7, like literals and switch, which allows strings and all, and try with resource we tried. So now we can see very important topic, which is Java 8 features. So these are very frequently people are asking in interviews. So what are the new features introduced in Java 8? So that much important it is. Features of Java 8. The first feature I can say lambda expressions. So lambda expression is very much helpful in programming. This makes you developer life easy, and you can able to code with very much minimal lines of code. If you compare to Java 8 code, Java 7 coding, and if you compare with Java 8 coding, so there will be a lot of benefits you'll be getting. So you can optimize your code, like a small amount of code you can write. You can achieve big functionality with that. So these are one of the major feature out of it. And the next feature will be method references. System got stuck. Method references. And third feature will be functional interface. So all are correlated. Once we start programming, get to know all these things. The next feature will be streams. Stream filter. So these are also very good feature we introduced in Java 8. This will help a lot of times. The next feature we're going to discuss about default methods. This looks new for you. This default method comes under interfaces. We can see it in this tutorial. And the most popular for each. At last, we have a new feature called string joiner. So these are all the features we're going to discuss about features of Java 8 in this tutorial. We can see one by one how these features are useful and what are the major advantages of using these features. First, we can see lambda expressions. So lambda expression, it's a very important feature, I can say. Uh, with the lambda expression, you can able to provide the implementation very minimal code. So the lambda expression is particularly used to provide an implementation of an interface. It's not a regular interface, it's a functional interface. For a functional interface will be providing an implementation. So this actually takes very less code for you. The lambda expression, if you see, the syntax will be, let me get this out. I'll show you the sample syntax, how it actually looks like. Suppose if you have a method which will actually takes a number of parameters, and it will actually have a body. So what actually method will have a method name and parameters and method body. So in lambda, using lambda expression, we don't need to have method name itself. We can directly, when you're calling a method, so you don't need to have these method names and all. You just need to have, depends on the parameters, you can directly call that method. The way to do this is, any arguments you have, argument list you have to pass, and these are typical syntax for that. And this syntax you have to use to make these typical syntax will be using for mentioning referring lambda expression and your body. Whatever the body is there, you have to have your body here. So using this syntax, you can able to provide an implementation for any functional interface. Suppose if your interface is having only one method, which is called as a functional interface. We can see it in detail when we are discussing in functional interface. So it will have only one abstract method. It doesn't have any more than one abstract method. It should have only one abstract method, that is called as functional interface. So to provide the implementation, we'll be using lambda expressions in this manner. We'll see the example how actually looks like. Suppose if this is the argumented list, right? If you don't have any parameters, so how it actually looks like if no argument there is a method. So how we actually define the syntax for that? If there is no argument, the syntax will be just write it this parenthesis, open and close parenthesis, then use lambda expression, then you just write your body, whatever body you have, the implementation of the method. So you just write your body of the method. That's it. These about no argument implementation. Like if you how to implement no argument functional interface method means these are you have to use it. If you have one argument, then the syntax will be, suppose if you have only one argument, which is a1, that's it, use lambda expression, then your body, whatever method body, you can write it over here. So if you have two arguments, two or more arguments, or two arguments, suppose if you take two arguments, then the syntax will be argument 1 comma argument 2, that's it. You can write your own, sorry I missed to mention lambda expression, this is very important. Then you can directly write your body of the method. So these are you will be having a different types of if you have three arguments, obviously you can have one more comma and you can be adding a3 and you will be writing your implementation. These are the lambda expressions actually looks like for syntactically. So as I mentioned, a function providing an implementation for a lambda expression, providing an implementation for a functional interface is called as lambda expression. So what is a functional interface? A functional interface which have only one abstract method, not more than that. So that is called as a functional interface. We can see it practically how actually this looks like. First we can see without lambda expression how actually we can declare a class and how we actually use it, and with the functional interface how we can actually achieve it. For that, what we have to do, before writing any lambda expression, what should we have? Any functional interface we should have, then only you can able to achieve implementation. So it's an implementation for lambda for functional interface. So if you are implementing any functional interface, that is called as lambda expression. You can see it in practical now. So first what I'm doing is I'm just creating an interface like a functional interface which will actually contains only one abstract method. Then I'll be trying a regular code how actually using that interface, and later I'll be going for lambda expression how to code optimization will happen there. You can see it now. So for that what I'm doing is, let me close all my other windows. So I'll be having a Java 8 package there. I can use it for my examples for Java 8 features. So I'll be creating a interface. So as I mentioned, first we have to create an interface, which from where we can able to implement Lambda expressions. So the interface name I'm just creating drawable. So this is just an interface. What this should have only one abstract method. Then only it is called as functional interface. That's it. So this is my interface. So first I'm doing without lambda expression how I'm actually achieving this, and next we can see how to achieve with lambda. So I'll be having on class which is without lambda expression. In a regular code how actually implement that. So what I'm doing is I'm just having a main method. So in main method I want to use that interface which is drawable. So this is the implementation I'm providing here. So this kind of implementation is called as anonymous declarations. So these are way of if you're gone through my inner classes tutorial, then you get to know what is anonymous implementation. So any interface if you're directly implementing, if you're directly using that interface by creating a reference variable, that is called as anonymous implementation. So what I did was I just created an reference for drawable interface, then I'm providing an implementation for that. So what all abstracts methods I have, I should override those methods. I should provide implementation for that. I'm just writing a method I'm drawing fine. I just wrote a method which is, or I can have one more variable out of it, and so that I can able to access that outside that width 20. So I'm just having one variable without printing value directly. I'm just having drawing width of width. So this is a simple implementation, anonymous way. I'm just implementing that interface. Now we can reuse that reference t dot draw. So the expected output will be I'm drawing width of 20. We'll say it now. See, it's giving an output. So this is without lambda expression. This everyone knows that how to use without lambda expression. Now we can see how to create with lambda expression. So I'm just creating one more class so that we can able to compare two classes. So this is with lambda expression. The same way I'll be having a main method, and here what I'm doing is I'm just having same width, or I can have different width to make sure your output will be different than the previous program. So I'm using lambda here. So the same way, like how we have a drawable reference, right? The same way I'll be having a reference variable here. Here, the actual story comes. So what I'm doing here is without lambda. So I'm just creating a new instance for that, and again I'm overriding that method. Inside that, I'm just writing my block of code, the body of the method. I'm just writing here. So whatever my logic, I'm putting here. So with the lambda, you can avoid all these steps. How to do that? We'll see it here. So if you see this example, right, if you see the interface, right, what the interface we have, as I mentioned in the lambda expression syntax, so if there is no arguments, then you just need to write this way of implementation. If this is having any argument, no. So which will suit this type of implementation is sufficient for us. If it is having any type of irrespective of data type, these are syntax for a lambda expression with two arguments. Irrespective of parameter data types, these are syntax for one argument. So likewise, we can there is no data type restriction over here. So with any data type, we can have this kind of implementation. So the compiler will automatically see how actually the function interface method will look like. So to make sure, I'm covering functional interface also here along with the lambda expression. So to make sure this syntax will match, here we have only without argument, we have functional interface, only one method it is having. So I'm just using this kind of syntax. Let us go and try that. So there's no argument and I'm using a lambda expression. Then I'm just providing an implementation. See, there's no errors at all. Now what I'll write is, what are the code we write here, the block of code. I'm just writing a similar code. I'm just prefixing lambda before that so that you can see the difference output here. So that's it. So these equals to this block of code, whatever block of code you wrote, right? So with this block of code, these equal. So then what I'll do is d dot draw. That's it. Let us run this program. See, now you're getting with the lambda, you'll be getting the latest value, which is 40. So these are typical syntax you have to use for writing any lambda expression. So these about without any argument. So if you have any return value, how to do that? Now we can see it now. So this is not having any return value, right? This drawable method is not having any method. Can I write one more method here? Am I allowed to write? So this will never throw any exception even if you write, because it's treated as normal interface. Because this is a normal interface, this will not throw any error. But to make sure this is a functional interface, you cannot have multiple methods. It should have only one method. To make sure the compiler will understand better and even the other developers should understand better, it should have only one method, because I'm treating this as functional interface. If you mention multiple methods, it actually it will not treat as the functional interface, and you can go to the implementation, what are the implementation we wrote here, right? And if you go there, then it will actually throw the error saying the target expression must be in a functional interface. Here it is simply telling the target type of expression must be a functional interface. It's not a functional interface, because you will be having multiple methods over here. So you cannot have multiple methods in a functional interface. To make sure the compiler will understand better, and to make sure the developers will remember this is a functional interface, we cannot have multiple methods inside that. We can have an annotation which is functional interface. So if you mention this means this particular interface will have only one abstract method, nothing much. So you cannot this by seeing this the other developers also can understand we cannot have multiple methods inside the function interface. So there's I can say it's a mark we will be giving to other developers so that they can, by seeing this symbol, they can understand. So they cannot have multiple methods inside that. And if we make multiple methods, then the lambda expression will fail. Simply says it's not a functional interface. As simple as that. Let us try with a different example, which will take two integer values and it will actually return uh, an integer, sum of the integers. So what it will cover, it will actually takes two inputs a and b, and it will add those elements, it will actually return that. Let us write a functional interface for that, and we can go with the lambda expression. We know how to call a regular way. Now we can see how to call the lambda expression. I'm just closing these things. So I'm just creating a functional interface which name as addable. So I'm just making one method which is int add. I'm just taking two inputs, int a, int b. That's it. To make this as functional interface, I'm just annotating with functional interface. So this I'm ready with the functional interface, which have only one abstract method. Now I can go and use a lambda expression. We know how to implement this in a regular way. Like you just need to implement this interface, and you can have you override this add method, and you can have the provide the implementation like return a plus b and all. So the implementation will be huge. With the lambda, how to achieve, we can see it now. Just creating a new class. So I'm just having one more example. So the regular way will be, let me write with regular way for addable. So these are regular way. You just need to have return a plus b, and wherever you're calling, so I'm just renaming this as obj. So wherever you're calling, add obj dot add of 10, 20, then you will be getting a 30 as a result. So this is what I expected. So these were the standard way of writing a regular interface with the anonymous implementation. So these are we'll be having a code for that. So this much code we have for that, right? So to do that using lambda expression, we can go back to our diagram. Here you can see if we have two arguments, the implementation will be a1, a2, and simply call body for that. Let us try here. You don't need to have this. Remove it and put a comma b, and the body you don't need to have whole the thing. Just remove all these things. Remove it and make sure to add a lambda expression. That's it. This will work. So it gives you 30. So I'm just clearing. I'm running as Java application. So it's giving 30. So I don't even want to have even I still want to optimize this code. What is the way to do that? So there is a way to do that. So now with the syntactically whatever we mentioned here with the two arguments, we should pass two arguments over there and we should provide the implementation. If it is having return in the body, then we can have return, because this functional interface method is expecting a return type of integer. So this is what we are doing here, and we will be using that object in sysout. So we can even still optimize this code. The way to do this is, as it is a returning single integer element, so we can remove this return also. We can remove the return statement, and this block we can remove. The simplest way it is just need to write a plus b, as simple as that. So you don't need to have that much lines of code. Even if it is a very small operation, then you can directly have, if you have big operation, then it's good to have a open and closing parenthesis. Then there you can write your block of code and you can return the object. If you have very minimum code, then this much optimization is will work actually. We'll see the result now. See, now we got the result. So these are best examples I can give for the lambda expressions. So we can even try with different approaches, like with different types of interfaces and different types of custom objects. Here I just taken integer primitive types, and you can take custom objects. There you can try multiple ways, and these way of implementing a lambda expression. The only thing is you should have a functional interface. What is a functional interface? An interface which have only one abstract method called as functional interface. So lambda expression will be the implementation for the functional interface. So the implementation depends on the type of the method, depends on the number of the arguments it is taking, and the return, if it is returning or not, depends on the syntax of the functional interface method. So we can write lambda expression code. So that's about it. Now we can see, so far we covered lambda expressions and functional interfaces together. Now we can see the method references. So what is a method reference? A method reference, it's a feature provided in Java 8. The method reference is used to refer a method of an functional interface. It's again, it depends on the functional interface. So if the method reference, again, it actually look for the functional interface. There it actually identify the method. So depends on that, it will actually provide the references for that methods. We'll see there are different types of method references are available. We can see it, what and all types are there, and how we can achieve them. Let me clear this. So now we are looking at method references. As I mentioned, method references also depends on the functional interfaces. We can see what and all different types of method references are available. So there are three types of method references are available. One is a reference to a static method. So if you have a function interface having static method, then it will actually refer to that method, and reference to an instance method, and refers to a constructor. Let me write here. So it's not a refer, it's a reference. So as I mentioned, there are three types of method references we have. One is reference to a static method, other one is reference to uh, an instance method, and reference to an constructor. We can see one by one now how what is actually means and how actually create a method reference objects. Suppose as I mentioned, so these also depends on the functional interface. I'll be using the available functional interfaces, and like addable or drawable, anything I can use it, or I can have my own function interface for that, for the implement, for referring the method interfaces. Let me have an interface separately. I'm just saying a message like sayable or something. Sayable is the interface where I have only one method, which is say. That's it. I'm just pointing this as function interface. Now I'll be creating a new class which actually refers like method reference implementation. I'll be having a main method there. I can actually reuse the there actually I'll be testing it. Before that, in this reference, what I'll be using is I'll be writing a duplicate method or kind of reference method for the save method. Here we'll be having a save method, right? For that, I'll be writing one duplicate method or reference method. So as I mentioned, the first we are going to see the static implementation, right? Reference to a static method. So I'll be having a method which is static. The way to do this is public static. So what is the return type of this method? It's a void. So I'll be having the same type. So you don't need to have the same name here. So if you are giving reference, right, it kind of alias. Suppose if anyone will have one original name and they'll be having a um, uh, pet name or something. So parents will call with a different name from the childhood, and they'll be having one name. So these kind of similar functionality here. So we'll be having a sayable interface, which is actually the original name was say. What I'm doing is I'm giving a different name for that. So with the same syntax, I'll be writing a method, and here I'm writing hello and static method. That's it. So now we have provided a reference method for sayable interface. Now you can ask where we didn't even implemented that one and how to actually refer that. We'll see it here. So we don't need to implement that sayable interface here if you want to create a method reference. That's the advantage in Java 8. So you don't need to have one particular implementing sayable and you have to override that method and all. You can have your own method in a different way. Like even I make it static. Even this is I didn't mention any specifiers and all. I just want to mention method reference with static. So I just make this static, and the syntax, the return type is same, which is similar to the sayable, and the name I changed up according to my name. So it's a different method, completely different method. It's not even related to sayable, but it actually, this syntactically it looks same because of the return type it is having. It should same. Let me make them together, like let bind them, like to make use of method reference. Let's see it here. What I'm doing is I'm taking a reference for sayable, reference variable for sayable. This interface, I'm just taking a reference variable. What I'm trying to do is, instead of this method, I'll be referring this method here. The way to do this is take this class and put two colons. Then you can call this method directly. Say something. That's it. See, there is no compilation errors. So we just created a method reference for sayable interface say method. The way to do this is you just need to have a duplicate method kind of thing, and with a different name, and the access specifier you can add it if you want to refer the static method reference, and we have the object is ready. Now we can test that. Sayable dot say. I'm just referring because this interface will have only say method accessible, right? So I'm just calling this method, and nowhere this implementation is provided, and the implementation actually provided for say something, and what we are doing is instead of that say method we are actually referring this method. We'll see the output now how it actually looks like. See, the method got called. Even if you call the sayable say method, the method got injected and it got the output what we expected. So these are a way of using referring a static method. So I'm giving you an assignment for rest of the types like instance methods and constructors. And as time being, so we should move to J2EE concepts first. So that's a priority for us. And so if you explain this much in interviews, that will be more than enough. And if we just go through the other types of method references, which is uh, instance method and the constructor, make sure guys it requires even lambda expressions and method references are required a function interface, that is mandatory. Now we can see the next topic, very important topic, this is which is stream. So now we can see what is a stream. Stream is called as suppose in files we'll be having some file streams, and in water we'll be calling as water streams, and different streams we'll be having, right? What is this Java 8 stream? So this Java 8 stream actually used for operating your elements in functional style. So if you want to operate the objects like lists and all, if you want to loop them and if you want to filter them, so many things. If you're it is good to know about stream classes, because it's because of the streams you can able to process the object very easily, and you can print the elements like very easy manner. We can see it now how actually use streams. So first we can see the benefits of using streams, so then we can go to the examples. So the first benefit I can say, stream does not store any elements. Suppose if I'll give one simple example. So with the if you have any array list, and it will have some it is holding some elements, and you just need to loop through them. So you can use streams for that. So you can just tag stream for a list, and you can have you can print all the elements, and if you want to filter any elements you can do it with the streams filters, and which is the next topic, stream filter. So so many operations you can do it in instantly, but stream will not store any element. It just kind of buffer, it just get those elements, it will give you the output, that's it. It won't store any elements inside it. So stream is a lazy and evaluates code only when required. Uh, Only when whenever required, then only it will actually evaluate it, and it won't even much bother about what contents are actually inside the objects and all. So it's like a iterator, I can say. The stream, whatever stream we have, right? It is actually kind of iterator in terms of lists and collections and all. We can see it in practical now. How actually streams will work. We can see it in practical right now. So for that, what I'm doing is I'm just creating a class. Sample class which is named as, I'm just having a class name as product. This is a simple class where I have properties of ID, name of the product, and obviously the price. So these are all the properties I have. I just want to inject an constructor to feed these values. So I'm just preparing this product object so that we can reuse it in streams and the stream filters. For both the concept, this class will be sufficient enough to test it. So that's about this class. So our product class is ready now, and we can go to the stream example now. So these stream example I'll be writing. I just let me have one main method over here. Typo. So what I'll be doing is first I'll be creating a list of products. With the list of products, if I have the list of products there, I can use stream and stream filters and all. We can do lot many operations over there. We'll see it here. Let me have one list which actually takes product type. Let me have imports, Control Shift O. I'll name it as product list. Array list. So I'll be importing from util.list. So my product list is ready. I'm just adding the elements. What is the type of list? It's a product, right? New product of ID 1 HP laptop. Price will be 25,000. So let me have multiple products to be added. 2, 3, 4, 5 products I have. One is HP laptop, other one is Dell, Lenovo, Sony laptop, and Apple laptop. The prices I'll be having at different prices. One is 25, other one is 30. Let me have a different price which is 28. Again, this is also 28. This is about 90,000. It's more than that actually. So I'll be having a product list which is having a 5 different products of laptops, different laptops I'll be having. Now we can see how actually streams will perform operations in this particular list. So how actually it will be avoiding lots of lines of code we'll be writing in a layer. Make sure guys this will be the very extensive feature we'll be using in real time very frequently. Let's go and see this. So I just want to print these elements. What will you do? Or without using streams, what will you do? For each loop, even if you use for each loop, you have to use product p equal to p colon product list you have to give, then you have to go to and p dot name you will be writing. So let us run this program. It actually print all the names of the products, right? This is simple. So why do we need streams actually? So I'll give you this scenario. If you want to filter all these laptops only if it is having 30,000 as the price, so what you have to do for that, you have to do is, so my condition is to check if it is having 28,000 or 30,000 or whatever the amount, and let me go with the 28,000. Print only laptops which are actually having 28,000 price. For that, what it will do, if of p dot price is equal to 28,000, then only you will be printing these elements. So what all elements are there at the 28, which is Lenovo and Sony, right? We got the output Lenovo and Sony. So we have to write this much lines of code, and if you don't even use for each loop, then you have to write lot much code maintaining the indexes and all. You have to write it. To avoid that, the streams came. Not only these features, we have a lot of features with the streams. So I'm just commented this code, just clearing this output. Now I'll be using a stream way to print these elements with the same approach. Let me print all the elements with the stream first, then we can see. For that, you just need the name of the list, then put dot stream. So see, it is taking a collection. It is taking any collection. Each collection will have a stream method. So these are the list I have, and this list by default it's have a stream method. It actually holds all the elements of product type. Then what you have to do, you have to loop through the elements, right, to print that. For that, for each, that's it. Just write product and lambda function, lambda expression you have to use, then sys out. What you want to print, product dot name. That's it. See, with these many lines, you just wrote it in single line. We'll see the output. What is expected? It should print all the names. It is printing all the names. So like how we did the condition check, how we are actually checking it, right? Which comes under the filter. The stream filter will cover adding more filters to it. So here the filter will be filtering the elements only which have 28,000 price. The way to do that is, let me have a separate line to make understand better. Just write a filter of your condition. Product dot price. What's your condition? It's around 28,000. Let's print that. The expected will be Lenovo and Sony, right? We'll see the result now. See how simple it is. You just need to have a stream there. You just need to, for printing elements for each loop we will be using, and for filtering you just need to have a filter and printing all the elements. Also you can do a lot of operations over here. Suppose if you want to total the price of all the elements, so what is the way to do this? So suppose I want all the elements, like all the laptops overall price, how it is actually costing. So in regular way, what is the way? You have to loop through the element, you have to get the price, and you have to create a global variable and I have to add it, right? But here you don't need to have these things. You just have one with the stream. You just need to have uh, some of the elements. You can do it in inline itself. We can see it right now. What I'm doing is I'm just taking product list dot stream dot map. So which one you want to uh, make it consideration, which is our price only. We are calculating consideration here, right? Just need to write which property it is. Product dot price. So now our property is ready. Now we have to do the sum of the elements. The way to do this is just write reduce of what kind of operation you have to do. It's a what kind of object it is. It's kind of float, right? I'm just giving 0 f. The type will be float. So what operation you have to do? Sum you have to do. So this is the typical syntax of having a sum. So this will actually return the sum of the values, and you will be keeping in a float variable. So I'm just printing this value. We'll print the sums now. See, we'll be printing the sum, which is 2,01,000. So these are we can use. There are a lot of methods you can go through one by one, and so far I mentioned a very frequently used methods like for each leaf, which actually loop through the element, and the filter, which actually have filters. You can have more filters by adding and condition. You can put more filters here, and for having some kind of if you want to do some addition operations or something, so you can use sum and all, and these are we can able to perform lot of operation with the stream and the stream filters. So these are very important topic, and make sure guys you have to hands-on experience in this so that you can clear the interviews very easily. So that's I suggest you to go through the all examples one by one in practical so that you can have better knowledge on it. So let's go to the next topic, which is so far we covered streams and stream filters. So stream filters we covered here with filtering the objects within the list, and you can try the stream for different types of objects like set. You can try on maps. You can try for all other collection classes. And now we are going forward to the default methods. So what is a default method? So the default method is called, if you yeah, in Java 8 onwards, the interfaces will allow a default method with the implementation. Even the functional interfaces will allow you to write a default method. Suppose Sable is a functional interface we have, and in this method, usually suppose if you write before Java 8 and all, if you write any method, suppose if I say like void print me, a print method. So before Java 8 and all, if you write any method in within interface with the implementation, then it will actually throw an error saying this is not abstract method. Abstract method will not contain a body. But in Java 8, they introduced you can able to write implementation for n number of methods, but make sure these methods will have the default methods. For that, you have to do a prefix with default keyword. So that's it, errors are gone. So you can have n number of default methods in a functional interface, but make sure you should have only one abstract method. If you have more abstract method, then other classes wherever it is using, it will actually throw you an error. So these are one important feature, and when you're coding your project in Java 8 and all, then you can use these default methods in your functional interfaces. So these are new feature introduced in Java 8. So that's it for default methods. So for each loop, so there is a feature called for each, and this for each we already covered in the stream list, which is same, and you can have if you want to loop through this element, right? Even if without stream also you can do, just for each only, not for other filters and all. You just have for each directly. So you just need to have so these we can directly use a for each loop for the any kind of collection. So what it will do is you don't need to use streams for that. If you just want to use for each loop alone, like how we did here, instead of that, in this you can directly use any list dot for each of that element. You can loop through the elements, and if you want to make any filters or something, and if you want to do any sum of operations kind of thing, and if you want to do any operation, then it's good to use streams. For just looping, it's good enough to use for each itself. It is straightly available in any collection classes like array list and all. So that's about for each loop. Now we can see the interesting class, which is string joiner. How it actually looks like, how it is useful in real time. Suppose if I have a string like suppose if I have strings like what I can say, it's name 1, name 2, name 3, name 4. So a lot of strings. Suppose I have thousands of names. So thousands of name I have. What I want to do is I have a these names in a list or something. I just want to have one delimiter out of it. Suppose these 1,000 names in a particular list you will be having, and you just want to add in a delimiter out of it. And I just want to print names like name 1, comma name 2, comma name 3. So likewise, I want to print all the names. So when I'm entering, I'll be having any kind of list, and I just want to when I'm accessing that value, I just want to access it as a string. I just want to have it in this format, or any delimiter. This is a delimiter, I can say, and you can have any delimiter. Or if I have a list of elements, I just want to have a result like all the elements within this format. So how to do that? What actually we'll do before this feature is available, like string joiners and all available, we'll be using we'll be looping through the elements, and we'll be having one string there. We're actually appending that strings to the result, and then we'll be using it. But with the string joiner, it's pretty easy to do these operations. Suppose if you have a list of elements, and you can, if you want to put it in different format, like the delimiters and all, you can, if you want to add it to like before and after brackets and all, comma and all, if you want to add it, you can simply do that. Let's go and see the example how actually we'll implement this one. I'm just creating a class which is string joiner example. I'm just having a main method over it. So what this main method will have, our implementation of string joiner. So there is a class directly available which is string joiner. It's come from java.util join names new string join of. I'll be giving the delimiter as comma. I just want to delimit with comma values. Now this will actually treat as a list, and you can have add elements and number of elements you can add it. So I'll be adding name 1, like how we discussed in this example. The same way I'm doing it. So I'll be having 4 names, name 2, name 3 and name 4. I'll be having 4 names. We'll see how actually it actually print if you just print this element, right, with the join names. It will actually print the elements with the delimiter comma, like how this format is looking like. So we haven't added parentheses so far. I'm just printing the elements with the comma delimiter because I just added a comma delimiter here. Let's go and run the program. See, now the elements got printed with comma separated values. And now what I'll do is I just want to have open and close parentheses on or before the methods. The way to do this is you just need to add 2 more delimiters, which is your opening and the closing parentheses. Just adding 1 delimiter for opening parentheses and 1 more with closing. Anything you can put it, any special character you want, you can put it over there. So now the expected output will be open parentheses names with the comma separated values and close parentheses. Let's run this program. See, we got the expected output. So these are all the major features of Java 8, I can say, which is lambda expression and method references and the functional interfaces and the streams which we are using for list and other collections. And the stream filter will be using, if you want to filter any elements out of it, the stream filters, you can use it directly. So these about the features about and also we covered string joiner, which actually gives you the output of separating using delimiter. You can able to have a formatted string out of the list of elements. And we also seen for each loop, so you don't need to have for each loop you have to use it, and you can directly use for each keyword and you can loop through the elements like how we did here. So these are all the major features of Java 8. So let's go and see the features of Java 9 now. So a lot of people are using Java 8. So these, make sure these operations, whatever we're doing here, lambda expressions and all, it should be very much hands-on experience. And Java 9 still not yet used in real time, but it's good to have some knowledge out of it. So I'll talk about very few features out of it with the Java 9 because it's not much stable in real time. People are not much using it. Few projects are actually trying to have migrated to Java 11 also, but they are not functionally migrated. It's like they're doing some kind of trial and error. But the Java 8 is stable so far, so people are using it. So with the Java 9, the features will be, I can say, the private methods in interfaces. So like how we have a default method in interface, right? We have a default method interface, right? Likewise, they have a private method. Private methods also introduced along with the default methods in Java 9. Methods in interface. So these are very useful features, and you can have implementation for private methods in Java 9. And the other feature will be the factory methods. The factory methods, I can say the features are looking like, suppose if you have what we are actually doing is we are suppose if you want to create a list, what we are doing is list of integer lt equal to new array list. So these are standard way of declaring an array list, right? Even if it is Java 6 or 7 or 8. So with the Java 9, these kind of operations are avoided, and we'll be having suppose if you want to create a list in Java 9, right? It's simple as you just need to have list of integer lt equal to, you don't need to use a new keyword and all or a list and all. Later you will be adding the elements, right? Like lt dot add of 10 or something. So these all will be doing, right, in till Java 8. With Java 9 we don't need to do that much stuff actually. Let me get this more down. So in Java 9 you don't need to do all these things. You just need to have list dot of, and you can give what are the elements you want. So these equivalent to list dot add of 10, list of add of 20, and this list is ready with the elements of 10, 20, 30. And if you want to do here, like you should go and you should add lt dot add of 20 and followed by 30, you have to add it. But to avoid that, they just implemented the factory methods. You can directly initialize the list and you can have list dot off. You can directly give the elements over there. It will actually take elements. The same you can have for list also. You can use all set dot off. For set also set dot off of elements you can give. Elements you can give depends on the type, like how we declared in a list. So the same way you can have set of integer st equal to so for set also you will be having the similar implementation. Even for maps also they will be having a key pair value. Suppose if you have maps, right, I'll show you, this is important. Map, if you have, is about taking an integer and string and p equal to map dot of, just need to have all the values with key pair order. Like suppose if you have key pair order means, suppose the key first key will be 101, value will be value 1, and 102 value will be value 2. So likewise you can have map of elements. So this is still this space is not sufficient. So likewise you have to create a map. Suppose if you want to create a map, usually we have to create a new map and map that put of key comma value we are giving, right? But with just factory methods of Java 9, you don't need to do all this operation. You just need to have map dot of method with the factory method. This is the major benefit of using Java 9. And major changes, I can say these two, I can say it is as major changes. One is private methods in interface. In Java 8 we have default methods alone. Make sure guys don't confuse. And Java 8 is having only default methods in interface, and in like how we implemented here, Java 8 will have only default method with the implementation in a functional interface again. Or any other types of interfaces also will support default method declaration. Not only in function interface, all types of interfaces will support default methods. And in terms of Java 9, you can have, along with the default methods, you can have private methods as well. and there are a lot of new factory methods are available for all kind of collections like list, set, and map. So these are all about the latest features of Java specific to version. So the next video tutorial will start with advanced Java, which is J2EE tutorial. uh, it's a fifth video, I think. The next video will be there onwards. We'll be starting that. Thanks guys, thanks for watching.